This lesson will teach me to make appropriate assumptions when reading a diagram. So here's the warm-up that I kind of briefly discussed in class, and it says, what is the purpose of stating that a diagram is not drawn to scale? Well, the idea behind this is that you can't assume that when somebody draws a diagram, me for instance, that I've actually measured anything. For instance, angle R appears to be a 90-degree angle, but I didn't measure it when I drew it, so you can't make the assumption that it is. Same thing here. Angle B appears to be a 90-degree angle, but without a particular marking, you can't necessarily assume it. So there are some things that can be assumed in a diagram and other things, for instance, that can't be. So here's the kind of analogy that I gave in class. So let me show, okay, so here's a homework key from a previous day. And when we go over this in class, I'll talk to students and say, well, how did you know it was 180? And it always comes back to the fact is because these two angles were on the same line. Well, how did you know that they equaled 180? And students say, because I just do. I know that a line sums up to 180 degrees. So that's the idea that a linear pair can be assumed. I didn't have to tell you, hey, this thing is a line. You knew it was a line. You knew they added to 180. And the same idea, these two angles are vertical. If you recognize them as vertical angles, you know vertical angles to be congruent. I don't have to say, hey, by the way, these things are vertical. You know they're vertical by definition of vertical angles, so you set them equal. However, looking at this problem angle 5, if I asked you, how do you know that these angles are complementary, you're going to say it's because of this right angle marking. So I had to tell you that that was a right angle. Without that little marking, you wouldn't have been able to assume it. So the idea of today's lesson is I want to discuss what you can and can't assume from a diagram. So for instance, a right angle. A right angle has to be marked using that little box, or even in words for me to say in a diagram, hey, I intended a particular angle to be 90 degrees. It has to somehow be present, otherwise you can't assume it. Congruent angles. If you were to draw two angles, you can't just assume, for instance, you can't just assume that this angle D is the same as this angle O unless I mark it. So congruent angles, congruent segments have to be marked or have to be given to you. Linear pairs, however, I don't have to tell you that linear pairs are a linear pair. You can assume that things are a linear pair because of what you know about them, that they make a line. Vertical angles. Again, I don't have to tell you, hey, these things are vertical. You know what vertical angles are because you know the definition of vertical angles. Midpoint. If I were to draw you a segment and put a point on it, do you have any guarantee that that is the middle, the absolute perfect middle of the line? No, I didn't draw it so that it were perfect. I just threw it on there. So what you would need to see is you would have to see markings indicating that that thing's a midpoint. So a midpoint is not something that can be assumed. It is something that you have to be told using words or markings in a diagram. Segment addition postulate and angle addition postulate. Both of these mean a part plus a part equals the whole. These things can be assumed mainly because of that word postulate, but I don't have to tell you that a part of the segment added to the other part of the segment equal the whole thing. That's something that you all know. Supplementary. While linear pairs may be able to be assumed, supplementary angles may not. And the reason why is because even though linear pairs are always supplementary, supplementary angles don't always have to be a linear pair. So I'd have to somehow tell you that my intent was to make these two angles supplementary. Otherwise, you wouldn't be able to assume it. Same goes for complementary. I'd have to tell you that if I were to draw two angles, that I want both of these to end up being complementary in somehow way, shape, or form. A couple more. The idea of a bisector. And we have two different kinds of bisectors. We have angle bisectors. So look at this. Here's an angle, and here's a ray going up the middle. Now I just drew it. Is it exactly in the middle? Well, probably not. But if I wanted it to be an angle bisector, I'd have to somehow mark for you that that thing was intended to be exactly in the middle. Same thing with the segment bisector. If I have a segment and a line that goes through it, I just drew that. I didn't measure anything. So I'd have to mark for you that my intent was to make that in the middle. And then lastly, the idea of adjacent. Adjacent is a definition that leads you to a location. Adjacent just means that two angles are side by side. and you can assume two angles are side by side if you physically see them, or if you see them, those two angles are side by side. I'm not talking about their measurements or anything. I'm just giving them a location. So things that you can automatically assume, things that I don't need to tell you. Over here, these are things that you need to be told, either using words or markings. Excuse me. So here are a whole slew of things that have to deal with this diagram. So let's go ahead. It says angle J congruent to angle D. Can I assume that based on the diagram? And the answer here is yes, because of those curved markings. Those curved markings are there to indicate that those two angles are congruent. The next one, angle JAC, so this angle up here, and angle DAC, so this angle over here. Are these congruent? When I asked this question in class, a lot of students told me yes, because of the tick marks. Well, these tick marks are going to the sides. Then students said, well, yes, because of the curves. Well, the curves are going to angle J and angle D. Notice there are no markings up here. So no, these angles cannot be assumed congruent. Every year, every class period, somebody then says, well, what if, and they start giving me all these explanations. What if you turn the triangle or fold the triangle, or since you already know these sides and those sides must be congruent. And they start going down this whole path of all of these excuses or reasons as to why those angles could be congruent. I'm not asking you necessarily, are they or aren't they? I'm asking, can you make the conclusion from the diagram? Simply looking at this diagram, no, I cannot conclude they're congruent without further reasoning. Looking at letter C, it says angle JAE, so that angle up there, and angle EAF, so it's referring to these two over here. Are those two angles adjacent? Are they side by side and touching? Yep. And are they supplementary? Yes. When I ask students how they know those angles are supplementary, they're usually going to give me something that has to do with the fact that they lie on the same line. Those angles are a linear pair, and that's something that can be assumed when looking at a diagram. So that's a perfect explanation about why those two angles are adjacent and supplementary. Letter D. The measure of JCA, is it equal to measure of DAC? No, there's no markings. Letter E, it says the measure of, let me change colors, JAC, so this one again, and DAC, this one again. Does the measurement of that added to the measurement of that equal 180? Well, they don't lie on a straight line. I have no idea what their measurements are, so no, I can't tell right now. All right, the next one says segment AJ, and segment AD, are they congruent? Well, if you notice those two little tick marks, yes. And it's because that the figure was marked for us. We'll just go down here to letter H. It says, is C the midpoint of JD? So JD is that segment along the bottom, and C is a point on that segment. So looking here, the idea of a midpoint is the midpoint is exactly halfway, meaning that that distance is the same as that distance. There's no measurements and there's no markings. So C might be in the middle. I just can't tell by looking at the diagram. So can I make this assumption? No, because there's no markings. If you look back up at the list that you have in your page, midpoint is under that column heading where you need to have words or markings. Letter G, it says angle EAF, and angle JAD, are they vertical angles? Vertical angles are formed when two lines cross and they're opposite each other. So yes, these are vertical angles. How do you know that? It's because you know what vertical angles are by their definition. And then the last one down here, ask if ray AC bisects angle JAD. So here's JAD, and I'm asking, does this right here, does it cut that angle in half? Well, it goes through the center, And it may very well cut it in half. They sure look like they're the same on either side, but that would be me making an assumption. I don't know if they are. There's nothing to indicate their measurements, and there's no markings to indicate that they're congruent. So can I make that conclusion just by looking at the diagram? No, I can't. And again, it's because there are no markings. If you look back to that word bisector, that's under the column heading of needing markings or words. And again, I'm not saying that it doesn't bisect. I'm saying that I would need some reasoning to get there. In just looking at this diagram, I can't make that assumption. Couple more. It says use the diagram at the right. So it says angle BGC. So that's the 16, oopsies. That's the 16x minus 4. CGD is 2x plus 13. Gosh darn it. X plus 13. Looking at these curves, that's whoever drew the diagram, me, telling you that those two things are the same. So in your equation, go ahead and set them equal. For sake of time in my video, I'm not going to solve. You guys are capable of solving that on your own. And I think it actually gives us a decimal anyway. So you can solve on your own. Letter B, it says the angle FGE is 5x plus 10. If you notice, there's a 90-degree marking here. That's me telling you that this is a right angle. So given that you know it's a right angle, you know that this 5x plus 10 needs to equal 90 degrees. And again, you can go ahead and find x. For letter C, it says AE bisects FC. That means AE is coming in and it's cutting FC into two congruent pieces. So make those markings so that when you look at the diagram, you recognize that that segment FC has been cut in half. It then goes on to tell you that the length from F to G is 2y minus 1. And it tells you that the length from G to C is 3y minus 4. So those two distances are going to be equal. What a lot of students tell me is we've just gotten done working with linear pairs and they say, well, lines add up to 180. The angles on a line add up to 180. Here we're talking about a segment where this piece of the segment has the same length as that piece of the segment. So you're not dealing with an angle here, you're dealing with a segment. And again, you're capable, well, when we do this, I can do this quick. That gives me y equals 3, and it's asking for the length of FC. Well, F to C, if the y is 3, then that means 2 times 3 is 6, 6 minus 1 is 5, this whole length is 5. 3 times 3 is 9, minus 4 is 5, so that length's 5, and that length's 5, FC is 10. And then the last question here deals with vertical angles. Again, what are vertical angles? Vertical angles are formed when you intersect two lines. Looking at this diagram, there are only two lines that actually cross all the way through. There's this one here and this one here. So your vertical angles are, let me get a bigger marker, here, maybe here, and here is one pair of vertical angles, and here are the other pair of vertical angles. One thing I noticed in class is that students are still struggling naming angles. So this one up here is angle AGF, and it's congruent to this angle down here, which is angle CGE. And they're congruent because they're vertical. And then finishing up, angle FGE is this one down here in red, and the other one over there in red is angle AGC. And their measurement is 90 degrees because of that little mark right there. My 15-minute limit is just about up, and it's a good thing because I'm done. Please let me know if you have any questions. Thank you so much.